Alright, draft physics video. This one's going to take a while, probably a few parts, maybe, who knows, technical stuff on the function of gravity and the specifics of gravity waves and, you know, Hythloday's incredibly convoluted description of relativity, in the sense of he's saying it's not even a believed theory, and yet he's arguing that it's a legitimate equation for the creation of theory that defends gravitational waves, which he doesn't demonstrate anyway, but whatever. So, yeah, I mean, it's the lengths people go to. So I don't know if I need to preface this with anything beyond saying you could sort of understand this is a flow kind of an equation. That's what gravity is, and that's how Professor Susskind describes it, and he does it for a reason. Hythloday even plays a little clip of him. He does it because it's accurate. It accurately models exactly what gravity does. It behaves exactly as if this is what it was, a flow. And so you can think of this in two different ways. I could argue that you could understand how water molecules sort of stick to each other. So if I had a water droplet and I pushed it a little bit, you know, tried to move it, you know, move parts of it, big clumps of it go along because it sticks together. The molecules stick to each other. And it has a surface tension which complicates that even further. So it drags its friends with it. If I took a bucket of sand, there is no connection. So nothing's under tension, so to speak. The sand doesn't stick to each other. It doesn't drag each other with it. Now, if I wanted to make a flow work, whether I used water or sand, push works. If I push sand, that is, I blow it, it'll create a flow mechanism, as if the pieces of sand are connected to each other. They'll all move, they'll all do this thing. I couldn't pull on sand. I can't grab a grain of sand and pull on it and all the rest of the sand comes with it, like might happen with water. Water really won't do that, but the idea is if water goes down a drain, it takes the rest of the water with it. If sand goes down a drain, it's not going to take any sand with it. You'd have to put the sand in an hourglass and force it to go down the drain. It won't just get pulled along. But if I put pressure on it, if I push the sand, it will. Alright, so that's one way of pointing out how this is about a push force. 300 years ago, they rejected it, they mocked it. 200 years ago, they rejected it, they mocked it. Feynman, in the 50s, rejected it, mocked it. And so they're stuck with that history. So they just keep trying to come up with pull mechanisms because they were foolish enough to mock the right answer. And now they can't bear the humiliation of accepting that they wronged a bunch of good science because of their own prejudice. Okay.
You are struggling to understand general relativity and the metaphors which are used. I spent years getting them to drop the...
That's a lie. So, I mean, that's just silly, right? I'm not the one who keeps bringing up bent fabric. The highest viewed video on gravity on YouTube is a bent fabric video. I'm not the one who says this is what gravity is. That's what they're doing. So again, you don't take any responsibility for your own bad representation of science. The fact that they're teaching it badly, they're demonstrating it badly, and the theory is justified with bad examples. And you take no fucking responsibility for that and say something like, well, they just shouldn't do that because it has nothing to do with any bending of a fabric. Instead of saying they're wrong, you're saying somehow I'm wrong. No, I'm not wrong. If they're going to use it, I'm going to mock it. Because it's bad science, idiot.
The explicit use of or reliance upon the metaphor of the rubber diaphragm.
So let's understand, if they didn't do that, so if they didn't use their little diagrams and their little images of their vortex with little things spinning into the vortex. Ooh. If they didn't use this model, then they'd have to go to people and say, sorry, that was out of the frame. So here's the bent space model. Now if they didn't use this model, then they'd have to, with its infinite infinite. If they didn't use this model, then they'd have to go to people and say, no, what gravity really is that something is pulling from every direction into its center. There's a flow of space-time into the center of an object from all directions, and it just pulls into the center forever and ever and perpetually into any mass. It just pulls and pulls and pulls and pulls and pulls the bend, and that's the process. And they'd be stuck with something that doesn't look very complete at all, because somebody could do the obvious thing and say, what do you mean it pulls? It has arms or something? It's pulling on ropes? Where's it pulling? Where does it go? Where's all the stuff that goes in here? Where does it go? See, the particle model, it just goes straight the fuck through. No problem. You don't have to have the drain go anywhere. But if you make it a pull model, then you have to explain where you're pulling all this stuff. Where's it go? So I'm just saying that's why they don't do the correct model, the three-dimensional model, is because they can't make it make much sense.
You used to argue all the time that, general relativity is explaining gravity with gravity,
No, what I say all the time is the three-dimensional model is pull. I say it all the time. All the time I point out how in 3 dimensions this doesn't have anything to do with bending anything. It has to do with pulling stuff forever to a non-location, filling it up never. An infinite amount of pull. Pull. We can just pull. We can just put it in this place, this magical, it goes to the pull zone. Whatever.
Because with the diaphragm, you've got gravity with a ball rolling in to explain gravity, And I've explained that diaphragm is kind of an analogy of a projection. You've got a 3D object, you can shine a light through it onto a surface and get a 2D projection. Similarly with...
well, in no way that isn't a proper analogy. I can't shine a light on this 3-dimensional model and make it look anything like this 2-dimensional model. So that's absolute bullshit too. So just keep bullshitting.
General relativity, that uses... 4-dimensional, not spatial dimensions, 4-dimensional...
No, it uses 3 regular dimensions and 1 fake time dimension. So that's just bullshit too. They're real dimensions.
Matrix, that's 16 variables, or degrees of freedom, that they tend to say. And it's a poor choice of word, because degrees of freedom has a spatial connotation to it, and that's not always the case.
And whatever, that really doesn't have anything to do with it. You can say it has these 16 degrees of freedom or something, but all that's really explaining is how well the fluid pulls on other material objects, how much stickiness it has. That's all it's doing. It's all the tensor is doing.
So the first thing to note about general relativity is it's doomed. As I've uploaded the Messenger series by...
Alright, so just remember that. He said the general relativity is doomed, and later he shows the equation as if the equation isn't somehow doomed. So general relativity, what is doomed? If it isn't the equation that's doomed, what's doomed? And it just doesn't make any sense. Because then he's banging me over the head with the equation in the end of this video, as if the equation proves gravitational waves are possible, which it doesn't. I mean, it's just so stupid.
Nima Arkani Ahmed, entitled, Space-Time is Doomed.
Right, so because this guy says so, he says that that's what physics really believes. So even though none of the professors in colleges are teaching that, at Yale or Stanford or MIT, he says somehow that's the truth.
I'll let him reiterate here, that space-time is not fundamental, something's emergent, it's an emergent thing.
Whatever that even means, it's an emergent thing. Well, that's really descriptive. again, it's this idea that they have gravity, and then Einstein gave them this fake notion that the invisible space thing, the empty thing, has got pockets. I mean, it's doing something. And so they didn't make it real energy, where all they had to do was say, there's a bunch of sand in the universe. Okay, and the sand is moving the speed of light, and it's pushing things together. Things absorb the sand's energy and are moved by it.
You know, it's just that is to say, it's a convenient way of looking at it, and a convenient property for us to think of it that way.
So I think all of us believe that space-time doesn't really exist. Space-time is...
Okay, so almost all of us, I don't even know who he was talking about there. Again, like, that's not what they're teaching. It's certainly not in any of their talking head videos. I haven't seen it anywhere, the debate between Neil deGrasse Tyson and this guy over the validity of relativity.
Doomed and has to be replaced by some more primitive building blocks.
But let's not, you know...
So again, I would argue that yes, it's doomed. Both theories are bullshit. Quantum mechanics is silly because it's wave obsessed, and it's just nonsense. Waves don't come from nothing; they come from something. So again, they're not identifying the thing that causes the wave, like the water molecules cause the wave in water. They're not thinking about the mechanical process that creates the waves. Instead, they're just thinking about the waves. So, and this is true with gravity. They're not thinking about what the cause of the gravity is. They're just thinking about the fact that it's gravity, and they've also turned it into a wave now. This wave obsession is just so fucking ludicrous and stupid. Waves are a byproduct phenomenon. They are not the nature of anything in the universe. Nothing has as its fundamental function waving.
Which is almost all of us. Let's not just take his word for it. You know, there is another document.
So we got two talking heads, Sean Carroll and Anami Papani, and the rest, 90% of them, wouldn't agree with this statement that relativity is dead.
The one I referenced earlier, that's pretty poor, but it's lots of clippets, and a lot of them are concerned with this notion of different people speaking about the emergent property of space.
So I understand their replacement is string theory, or I think this guy, Sean Carroll, is a many worlds fanatic.
Time, space-time, time, space, space-time.
So there's different ways you can go. You can sort of try to say, well, Schrodinger's equation isn't quite right, we need to do something different for gravity. Or you can say, no, actually, the deepest level of physics, time is something special and fundamental, and this appearance of relativity in our world, that time and space are kind of on equal footing, that's just an approximation useful to our regime that might break down somewhere else.
And the...
Might. You know. So again, the idea that they have turned time into anything other than what it is, just a byproduct of the fact of having something moving slower than instantaneous. That's time. Time only exists because light doesn't move instantaneous speed. If it moved instantaneously, then there wouldn't be any time. But that's it. That's the only reason why time exists. It's because something's going slower than instantaneous speed. That's it. It's just a function. It's not special at all.
And that formulation, time would be more fundamental than space.
Exactly. I think that...
Well, I mean, everything's more fundamental than space because space is nothing at all. It's zero. It's the absence of function. The stuff moving away from each other is doing the function. The stuff in between isn't doing anything. Shit. So yes, everything is more functional than space.
That's a radical idea.
Yes.
Today.
I would say I would be very happy to support the proposition that time is either as or more fundamental than space. So I don't think...
Again, does that make any sense comparing nothing to a non-material function? I mean, you know, a consequence of something not moving instantaneously. It's like comparing nothing and a vacuum.
Space is not fundamental at all. I mean, in my personal view, I think it's crystal clear space is not fundamental.
So it's crystal clear that space is not fundamental. I don't even know how somebody rational would interpret that in the context of recognizing that space has been used as a placeholder for the word gravity. So then you have to call it ether or something. You have to come up with some other mechanical mechanism to defend your whatever. Space-time, well then it has to be if space isn't real. Time-time isn't going to work. You have to put something else in there. Ether time, bent ether time.
So let's not get too angry in the first place. Let's not accuse like dissident science does. Let's not accuse the high-end physicists and promulgators of high-end theoretical physics of, too heavily touting general relativity.
All right, so let's just understand. He says that that's the representation of high-end theoretical physics. These two characters. And that the majority of them aren't defending general relativity kind of aggressively. That's what hythloday thinks. That's his impression of the physicist he hears. Well, my impression is exactly the opposite. And I imagine dissident science's impression is exactly the opposite, especially when he plays clips of Neil deGrasse Tyson being quite assertive in the fact that there'll be nothing to replace general relativity because it answers all the questions.
Yeah, they understood, and they've understood all along, that it's simply a model.
Right, so it's simply a model, which he's really trying to say is it's simply an analogy to something completely made up and synthetic. And what it really is just a replacement for the truth, which is the force doesn't happen inside the matter. The force happens outside the matter. That's where the force comes from. That's where the energy comes from. It comes from the outside. It doesn't come from the matter. And the matter is just a consequential filter. It's getting hit by the water. It's getting hit by the sand. It's getting hit by the energy in the universe.
And models come and go. Models have successes. Models have failures. Models have weaknesses. And, well, general relativity.
So let's understand that when Susskind in Stanford does these gravity equations, he's basically saying this equation is a fluid equation. That it equals out to exactly the mechanics of a perfectly evenly pressurized fluid dynamic with a drain and a source. So you keep a supply that's free, and you drain based on the mass. So the mass says how big the drain is, and the amount of stuff going down the drain is regulated to be, the pressure is always even. Well, I mean, it's distributed as it would be in fluid. That is, the stuff close by moves quicker than the stuff further away because there's more stuff in the bigger circle. So the further away you go, the more fluid there is, so the slower it moves. The closer you get, the less fluid there is, the faster it moves. That equation is saying that. That's the truth.
It's not been demonstrated to fail. It has philosophical weaknesses and implications in relation to quantum mechanics that make us believe it's eventually going to be.
Well, it's only conflict with quantum mechanics is it's not quantum. It doesn't have an element. It's, again, fluid. It doesn't get to the source of the energy. Because, again, your source of energy is a mechanism of the drain pulling. Even a drain, like I said, is a false analogy, right? Because we know everything goes down drains or into holes because of gravity, right? Or a suction, like a vacuum cleaner. But if I was to reverse it, put the hole above, I'd have to create pressure from the outside for you to understand it would go in, right? It's like hythloday could take a dump in his toilet. Take all the water out of the toilet. Does the dump know where to go or how to go? No, it doesn't, because there's no water, okay? This is the water equation. Without the water, there's no movement. Nothing happens. And so that's how stupid this is. But you can understand that if I shoot sand into the toilet, it's going to flush, okay, if the only escape for the sand is that hole. The external pressure duplicates the internal mechanism perfectly, and it's rational. The push is rational. And that's how you think when you're in water. You don't think that the water's, the water's being pulled and it's pulling you with it. You think of the wave hitting you and pushing you towards the shore or away from the shore. It's pretty obvious what's happening to you in that circumstance, and you get the answer correct because you're not getting your brain muddled by this confusing nonsense of the infinite pull.
Replaced. So here is, general relativity. General relativity is not that Einstein said gravity is like a rubber band or a rubber sheet.
Yeah, he did do that actually. So don't say he didn't do that. He did use the analogy, and clearly, I saw this silly Eddington movie, right? Eddington and Einstein. Einstein's name's in it, and Eddington uses the tablecloth to do exactly the same thing. Now you could say, well, that's just fake. Okay, I would agree. It's probably just fake, but clearly that metaphor was there from the beginning. So don't, this pretense that this isn't dependent on some these analogies is just nonsense.
General relativity is not that Einstein said there are waves of gravity. General relativity.
So let's play what he just says, waves of gravity, because Einstein said there's no such thing. So again, let's just be clear. This came up because of blinking stars. So that was the idea of two stars rotating, one star on fire rotating around another star that wasn't on fire, or they're rotating around each other. It doesn't really matter. And you would have the circumstance where the lit star would be behind the unlit star, and you would have a lights out part. Okay, so you'd have light, and you'd have a little dark, a blink. And the question was, could gravity do the same thing? And Einstein said, no, in any real sense. It could from this distance, okay, from close, you could see it. But from far away, you'll never see the difference between this and this. Okay, this arrangement will be indistinguishable from this arrangement from a distance. And this goes back to the same thing with the sun, right? You could reduce the sun to two little bodies orbiting each other that were the size of a softball. As long as you put them in the same center of gravity where the sun is, you could have exactly the same amount of mass in that tiny area, and the Earth would be doing exactly what it's doing now. Wouldn't change a single thing regarding the Earth's rotation and orbit. Because it doesn't have, this stuff doesn't make any difference at a distance. And that's what Einstein said.
Is this equation. And if you took note from a recent book.
Understand that the only way it can make a difference when you're close is because these are cones of radiation that come off of these things. And so when they're in these two locations, these cones would be, less radiation in a sense from these two locations. All right, but eventually, okay, this cone will end up being exactly the same width as these cones. The lines will converge. And so there's a distance where this will come out to being exactly the same thing. And the same thing holds true. This is Maxwell's equations and Gauss's law and all that shit. Charges just add up. You could have 10 different charges of different values in a pile, and what you'll end up with at a distance is all you'll see is +4 or -3. You'll just see what it adds up to from a distance. Because you finally create a radius where the lines would all converge, where the cones of influence converge. You get the same amount in the same area. There's a point where you you absorb exactly the same amount from either arrangement, okay, at this location. They're exactly the same.
Or quite a long video, you'll see that it's about examining the consequences of that equation.
The real fun begins, and at some level the fun hasn't stopped since Ethan IP and many others after.
Yeah, so this guy's voice is really too funny just to take him seriously, but you know, that's not his fault, but it just kind of, I think he'd work on that a little bit so he could sound like he was 15 years old instead of 12, but, you know, I guess he just was too busy doing physics for that.
Him, including me, are working out the amazing consequences of that equation on the top right. And the consequence I want to tell you about today.
Right, so I'll play this video eventually. I'd really like to, just because it's full of horseshit. I mean, you can really illustrate where they cheat, and then they cheat here, and you can see all the overt cheats.
Okay, so it's a straw man to say that.
So I'm doing the straw manning when this is his guy. Here doing it again, doing the same bullshit. So it's my fault that they keep doing this, that they keep misrepresenting the truth. So the truth is it's not a cone, it's not a thing, no, it's going straight in. This thing is grabbing, pulling. Now, how do you draw that pulling thing? You could put little arms on here, I guess, and just pull, but it's pulling towards that center. Because if you make it a push, there you go, you're in my realm then. Then it's quite obvious that these are photons that are doing this.
The top-end physicists are dealing in unicorns. Yeah, they're imaginary. We can talk about them, but
well, again, this is how they're illustrating their own science. So they're clearly trying to make it look like a horsey, but it is a unicorn.
They're still imaginary. Right? They're dealing in models. That's all there is to it.
Oh, it's not a model. So again, that's not even fair. It's an analogy. This isn't a model, because it doesn't even come out accurately. So this is rubbish. It doesn't work. You know, I mean, unless you can create the frictionless fabric, which you can't. So as an analogy, it's bullshit.
They know that they're models. They know they're using metaphors to communicate an understanding to a non-technical audience.
So he keeps using this word non-technical when he's really the one who doesn't understand the technicalities. And the technicality is that you can't sell the truth because it doesn't make any sense. And so if they tried to sell the truth, people would say, well, why don't you just make this a push force? Why are you doing this silly pull thing? Why don't you just say the force is coming from the outside? The pressure comes from the outside and it pushes the shit down the toilet hole. Why this bullshit? Why this pull nonsense?
Who aren't really going to be able to grasp the maths. This equation...
Well, let's understand that the maths, as they call them, okay, are just formulaic relationships. So let's, even just looking at the C4 thing, okay, C to the speed of light to the fourth power has got to be an insanely huge number. Just insanely huge. But anyway, I mean, 3 million to the fourth power. No, it's hurt my brain.
Is in a compact form. Really, each of these variables, this T mu nu and G mu nu, and again G mu nu and R mu nu, are actually representative of 4x4 matrices.
Yes, which means they're already formulas. So these are already formulas, separate formulas. So this really isn't the formula. It's the formula of the formulas, which, just is more deception.
Where on the outside we just have constants multiplied by those, against those multiplied constants, multiplying those matrices. Oh, that was hard. So I'll show you, okay, the significance and the space energy.
See, all of this ends up with r squared in it somewhere. Like this half would be the r and the square's over here now, or one of these 4v's is really the r squared thing, but that's all this is really going to do. It's just an equation talking about fluid moving by the r squared rules, like a light bulb, half the distance 4 times the strength. 4 times weaker, or 4 times stronger if you're going out. Twice the distance, 4 times the hand thing. The hand here, okay, see the hand, 4 times bigger, 4 times smaller than the hand here. That's half the distance. That's the rule. So gravity gets weaker really fast, or you could say it gets stronger really fast if you're going into it. So let's understand that in gravitational waves, which this video gets to, when they say we're 120 million light years away, and it shakes rocks on the Earth to move these mirrors. So just imagine 100 million, okay, times being 100 million times closer at the inverse square law. That's a huge multiplication. So you're talking about something, the force being billions of times stronger at a location of, say, 10 light years away from this event, or 100 light years away from this event. The force would be insanely huge. So I'd like hythloday to diagram for me the mathematics that could possibly make sense of, say, a single sun 100,000 light years away from one of these gravitational wave events. And what would theoretically happen to that sun? How much energy would it get hit with in a millisecond?
The momentum tensor, T, if you think of it, it's actually got, you can think of it as having subparts, as having an energy density component, and an energy flow component, a singular time component.
This is really just the drag part here. So that's really just about how transparent or dense, how density affects how you move through the flow of the substance. So it's like kind of understanding that if you were a screen and you folded the screen in half, it would trap more stuff. And if you fold it in half again, it'll trap more stuff. And it's that kind of relationship that, depending on how your matter is arranged, and how it really doesn't matter is the key to that. Because the more you spread it out, it's going to have the same effect as concentrating it into a smaller, thicker way. So it's just how much the filter catches. How much drag there is when you put your screen in the water. And the screen is your mass.
And the 3x3 self-contained momentum flux or pressure stress element. This has got 16 components, or 16 degrees of freedom.
Right, and this all has to do with two. So I'll just point out again, when gravity happens between two objects, what happens is this body, let's say, it absorbs energy. It absorbs acceleration. So it gains acceleration by absorbing acceleration. So and the same thing's happening here. This body is also accelerating towards this body. So in the process, these two forces kind of obviously negate each other, in the sense that this shadow negates this shadow, and in a sense from out here and here you won't notice anything different, because this one took stuff going this way and this one took stuff going this way. So from your perspective, there's an equaling, because two opposites negated each other. So from here and here, nothing happened, beyond the fact that there's this total mass. But the motion doesn't make any difference in what you feel over here. Their acceleration towards each other won't change what you feel here. It won't make you move at all. And that's what he's trying to say. Gravitational waves, somehow these objects would move. And they don't. But anyway, what do I want to get? There was a more important point with this acceleration thing. And getting to the oh yeah, so the inverse square law. So what you have to understand is these things aren't acting. So I've drawn an image of on the website of the proton and electron interaction, And there's not really an inverse square problem here, just because these two bodies are acting directly with each other. But in gravity, what's happening is when this thing absorbs, say this object absorbs acceleration, and this one absorbs acceleration, it's really absorbing any acceleration. You know, you have to do this. Unlike hythloday, you have to think in terms of a more complex mathematics and relationships, and he's just too pedestrian to handle that. But what's really happening is any movement that has a component in this, let's call this the x direction and this the y direction. So anything that has a component in the x direction, that is some portion in this direction, some portion in the x direction, anything like that counts as acceleration this way. And so when there's this reciprocal effect, like I said, this one's absorbing energy that would have hit this one. So the energy doesn't hit this one, it absorbs energy this way. Well, what it's going to absorb is energy going this way, or this way, or this way, or this way, or this way. So it's going to absorb the energy in the entire 180-degree sphere side half circle. So anywhere in that half circle, it will absorb energy. So the gravity it's creating radiates in all these degrees, the entire facet, the entire face of the round ball. So it's like cutting a tennis ball in half. One half of the tennis ball will radiate the force back. So the gravity being caused by this object actually radiates out in all these directions. So it radiates back at the object, but it also radiates at all these directions. That is the inverse square law. That's what creates the reduction in the force, is the fact that the force is spread over both this way and these two dimensions. 2 dimensions of the tennis ball, the force is radiating out of. That's the inverse square law. That's why gravity is weakened. Because it's not a I move towards you and then every bit of movement I did creates gravity coming right back at me again. No, it comes out any face that's in my direction. Any direction that has a component in my direction is what the reciprocal force will be radiated out of. So anyway, that's what this is doing.
But they're not degrees of freedom like distance. They're not space scales. It's degrees of freedom tells us a bit of a dummy. They're except for the ones where dimensions, distance dimensions, are explicitly meant. They're just simple variables. This is the content. And as I've explained in a previous video, which I'll attach.
Yeah, whatever. Then there's nothing simple or any explanation where you just get to the simple components of what the thing is. The thing is acceleration and reciprocal effects of that acceleration. You are accelerating something. If I shoot something at if I shoot something at something from a gun, all right. So here's the object. So I shoot it with a gun. It has a velocity. It'll have an acceleration and a velocity. Now, there's not going to be any gravity because by shooting this bullet, I didn't absorb stuff that, the bullet didn't consume force that would have hit this object. This is new force, added force. So there's no gravity being created by velocity alone or acceleration alone. You have to actually absorb the energy that would have hit this object. So all acceleration, when Einstein said all accelerations are the same, they're really not. Gravity is a special kind of acceleration, and it's being created by the fact that the thing you're having gravity with, okay, you're absorbing energy that would have hit it, it's absorbing energy that would have hit you. Neither one of you are fired out of a gun. There's no other source of force. The force has to come from what you're getting shielded from. I really don't want to get into my theory to point that out, but I mean, that's the nature of it. They're very different sources of acceleration, and gravity isn't the same. The acceleration, the movement's the same. Velocity is always the same. You're going 60 miles an hour or you're going 60 miles an hour. So the velocity itself is the same. But how you derive it, how you generate it, those two things have very different sources. So consequently, all motion doesn't create gravity.
To the end of this, and what is often said is that this side is to do with energy, momentum, energy and mass, because energy is closely related to mass, if not the same thing. And the left.
Yeah. So again, if not the same thing, no, your mass is what makes you capable of shielding or absorbing stuff that hits you. So your mass makes you a finer screen. The more massive you are, the tighter the weave of the fabric that the fluid's trying to push through. So you trap more of it. You absorb more of it. The more you absorb, the faster you go. So, you know.
Hand side is to do with geometry. So you get the old trope trotted out that geometry tells mass what to do, how to travel, and mass tells geometry how to bend.
Right. So another cliche little fun word game, but doesn't really make any sense logically. If anybody has a brain, they can kind of figure out, well, geometry can't do that. Mass can't talk to geometry, and geometry doesn't talk to mass, and you know, that's just silly talk. There's a mechanism. That's just fucking bullshit.
It's a bit of a circular argument. But
yes, it's entirely a nonsensical. You know, let's just confirm it with a word game. It's crap science. To say that's a scientific explanation is just like me saying, well, of course God made God. Who else would have made God but God?
The point is, it's not actually an argument. It's a relationship that has been deemed must be satisfied in the governance of the law of gravity.
Well, again, it's just, you know, the only thing, there's only certain variables. There's mass, okay, that's a big one, and then there's the mass is, and then you have the nature of the pressure of the fluid. That the more mass of the two bodies, the more fluid flowing. I mean, I don't know how to, but I mean, there's no trick variables here. It's circular, it's spherical geometry with the inverse square law, a certain amount of absorbed energy in the form of acceleration. And that's all it is. There's nothing else happening. You know, of course, except for the force spilled in these directions that aren't accelerating anything in particular. Certainly nothing in the specific equation. The equation is going to deal with this body and this body. This extra energy is not going to be associated with anything. Extra energy in the form of an imbalance. It's obviously shadow, an expansion rather than a compression, if you have to use those words.
So,
but again, let's understand, this expansion and compression would make no difference how big or small this object is, as long as the center of gravity is where the mass is located. So as long as you locate a mass in a center of gravity, okay, at a specific point, it just doesn't matter how big it is when you're a distance away. From a certain distance, how big it is, whether it's this big or this big or this big, is totally irrelevant. And any associations it has with other objects becomes totally irrelevant once you're a certain distance away. That's why gravitational waves is a non-starter as a theoretical possibility in any sense beyond maybe if you go to Mars, you could detect a tiny fluctuation in gravitational potential when the moon and the Earth are lined up and when the moon and the Earth are like that. But you're not going to do it from, say, Saturn.
That's what I want to show you. So this idea of a flow in gravity. Yeah? At the beginning of this video that I uploaded a long time ago to illustrate the point that the flow, nobody's saying that space is flowing really. Well,
so just, you know, he's going to try to weasel out of the fact that that's exactly what the evidence indicates. It obeys exactly that dynamic. It's a perfect parallel. There's no flaw in the analogy. So again, if there's no flaw in the analogy, it would be kind of ludicrous not to say it must be working like that. There's got to be something moving. And it's moving by these rules that would be identical to the fact that if we just fill the universe full of invisible sand, moving the speed of light, and we create and we have it get absorbed, the energy get absorbed by the things it hits, it would create exactly the effect we observe. Exactly.
The attitude of the layman, but the layman shouldn't get so upset.
So again, he calls it layman science when this is what they're dependent on. They're dependent on these analogies. They're not. It's not layman. That's how they have to think about it, because that's how it works. You idiot.
If he wants to understand it more deeply and more thoroughly, he should do the study, and you'll find out that they don't really mean it. It's still just...
Yeah, they do really mean it. And there's no... Show me the evidence where they say, well, gee, when I'm at home, I just look at the equations and go, ooh, yeah, that geometry sure told that mass what to do, and yeah, that mass sure told that geometry a thing or two. No, I'm pretty damn fucking sure they don't do that. I'm pretty sure in their own brain, okay, they're thinking about it as a flow mechanic.
A metaphor that space flows.
There's a beautiful analogy between black holes and waterfalls, which actually lets us calculate all properties of black holes exactly.
So this is exactly my point, right? So he says exactly. So let's understand exactly. It works exactly like it. And the only issue is the waterfall the deficit or is the waterfall the push? So what part of this example is the sensible part? Now we know water falls because of gravity, so let's turn the waterfall upside down. And how can I make the water go up? Well, by pushing, right? Pulling's not going to work. I can't pull the water because the water doesn't stick to itself enough. The adhesion between the water molecules wouldn't be nearly good enough for me to pull the water up. But I could do it if I push the water. If I push the water, it'll go up. No problem. And if I put it in a weightless environment, it'll go up quite well. It'll keep going up really excellently. So yeah, it's a push universe. Pull is silly. Push is rational.
When you approach a waterfall, the river flows faster and faster. When you approach a black hole, it's not the water that flows faster, it's space itself.
So this is just, again, the idea of the circle size. So the smaller the circle gets, the faster the water moves because of the density and the lack of volume. You know. And the more volume you have out here, the slower it can go. The less urgent. How to say it? Less confinement. I mean, water. If I take a pipe, a big 4-inch pipe, and I make the water go through a 2-inch pipe, the velocity of the water has to double. Well, it has to quadruple. You know, because it's a volume thing. The volume is going to be 4 times smaller, even though the diameter is only twice as small. It's the same thing as the inverse square law.
Okay, space itself. This is a BBC primetime video, right? Meant for general consumption.
And regardless if it's meant for general consumption, the word was there. It works exactly like. That's the point. The point is whatever the mechanism is, it's like this. It's doing something like this. It's pushing things into each other or pulling them into each other because there's something happening. There's a thing working just like, exactly like, okay, it was dragging stuff along in a river.
to woo an audience. It's a little bit naughty, yes, but, you know, it's for general consumption.
So I'll just say again, he said the word exactly.
Now, if you want to get deeper as a layperson and not get do the full academic degree course in physics, then it's...
So again, I'll just argue, I've watched Susskind. He uses this analogy or metaphor extensively, and he does it because it works and it fits. He doesn't do it because it doesn't work and it doesn't fit. And the only way he can make it more perfect was just to acknowledge it's a push force. Just acknowledge it's the force of the river moving, not the pull of the drain.
Susskind offers what he calls a theoretical minimum, wherein he skimps. He doesn't try to gloss over issues. If there's maths to be dealt with, he deals with it, and he tries to take you as far and deep.
Yeah, well, the point is the math is this fluid equation. Einstein's equation is a fluid equation. That's the point. The point is the math is a phenomenon. The math is basically a mathematical formula of, I could write a mathematical formula, apparently I could, somebody could, that would accurately describe the poo going down the toilet. And it would have to be a rather complex formula. But that's all it is. It's a real formula. It's a real event. And gravity's a real event caused by real forces that behave just like fluids.
Intercurrent physics without skimping, but without burdening himself with undue exercises and ancillary topics, let's say. So,
quote mining coming right up, no doubt.
He explains that it's not really space flowing.
Velocity here would go like 1 over r squared. That's a useful analogy. That is not to say that space is a flow or anything. It's a mathematical analogy that's useful to understand the 1 over r squared force law, that it is mathematically similar to a field of velocity flow from a flow that's being...
Okay.
See, so again, mathematically similar, he said, but obviously the guy said exactly like, because it's exactly like. So again, he's saying, I don't know what it is. He's not giving an explanation of how it could be something else. He's just saying, well, I'm not saying space is water or, fluid, but yeah, it does act that way. Because again, getting into those questions, as soon as they allow themselves to turn this formula into a real mechanism, that is to recognize, okay, it's obviously a fluid formula, it's obviously exactly like a fluid formula for a circumstance we can make up with glass plates and an even pressure and blah blah blah. Then as soon as they start saying, well, let's put something real to that, it's going to become pretty obvious pretty quick that, as I pointed out, the push works without any help. The pull only works with some sort of, you're going to have to add something. You're going to have to create molecules of water that stick to each other. You're going to have a much more complicated equation.
It's not a flow of space. Right? Let's have that done with. Okay? Let's have that removed from the arguments.
See, for this to work, these have to be almost like strings that are getting pulled. Okay? They can't, it can't be just particles or sand, because to be pulled down, they have to stick to each other. But if you push them, then you don't have that problem. The pressure's always there. Can't be avoided.
Okey-dokey. So, what's that? There's, oh dear.
So here he is defending this equation. He says in the beginning of the video, this equation is bullshit. It's useless to physics. It's in the way. And here he is defending it.
This is take 2. In take 1, I've been on eBay and investigated some, for probably $10, $15, you can get a microwave leakage detector from a microwave oven or mobile phone even. to detect it.
Okay, so he goes on and on about this, and so this is a separate subject. I'm almost out of time, but do a brief thing on it. He still doesn't get that the microwave detector has to be able to detect when there's two different microwave signals out of phase, and it still has to be able to see the microwave wavelength. Now, the argument I would make is the detector probably can't do that. It can detect microwaves from one oven at a time, but if you have two ovens on at the same time and they're exactly 90 degrees out of phase, the detector probably won't be able to detect the microwaves. But obviously microwaves bounce off a lot of things, so it could obviously detect ones bouncing off your wall or something else, but it won't detect the ones from two equally distant sources that are 90 degrees out of phase. So this is a reception problem. Antennas are really bad receivers. They're not like your eyeball. Your eyeball is receiving, each individual photon hits an individual electron and creates each conduit. There's a wire from each pixel, okay, to a source. Like this screen has wires from each pixel. Okay, so each thing, there's no blending in the antenna, so to speak. An antenna is collecting everything. Alright, so all the electrical signals get mixed. So all you can get is the net byproduct of the electrical signal. You can't get the individual signals at individual locations. So anyway, the problem is the argument that hythloday is an understanding in the radar experiment. So here's the two radar guns, one detector. The argument is not that there isn't interference between the two signals that are out of phase. There is. The two signals end up canceling each other, and so you can't receive them because of this problem. As I pointed out, this signal, this wave, really just represents a line of photons hitting at a specific time, and they're dependent to be received on coming at a certain frequency. If I put one 90 degrees out of phase coming to the same location, I destroy that signal. I double the frequency. So you'd have to have a detector that detected twice the frequency. That's why I'm thinking it's better to use radio waves. But anyway, he goes through a whole, I'll make a video on it, but he's just, see, this is where he's just being a layman.